So, um, so as I said, like my name is Vincent. I've been at SoundCloud for 3 years now. Initially, I joined as a very junior iOS developer, and then I grew there, and I learned some other things. I learned Ruby. Our continuous integration system is written in Ruby. I've learned Scala, and now like I divide my time between working on the iOS app, the mobile API, and also like teaching new hires and other engineers at SoundCloud how to do iOS. And today I'm going to talk to you about our mobile continuous integration system. And mobile like is a very important word there. It's like the question that you would ask yourselves, like why would you invest so much time and effort into building a CI pipeline? And the thing to keep in mind is that like CI pipeline is the basics in all other kinds of software engineering. Like you wouldn't build a backend system without like a CI. It just like wouldn't make sense. Like all the tools are there. It's super easy. It's super easy. But on mobile, it's actually pretty hard. It's getting easier every year. Like there's tons of great open source software now to build a CI system. But when we started in 2012, like it was, not easy. But what does like a good mobile CI system gives you? Like it enables you to move fast, to keep your code base healthy, have confidence in your app, and ship reliable apps. So let's talk a little bit about reliable apps. At SoundCloud, when I joined, we still had what we call the old SoundCloud iOS app. It was pretty old. Like it was from the times of iOS 3, had been in the App Store since I think 2008, and it was just super old. And we were a little bit inexperienced back then, and we decided to rewrite the entire app. What came out of it is the new SoundCloud iOS application, which shipped last year. It has like this super fancy full-screen player, parallax cells in the stream. It looks like really cool. And the thing with it is like we started from scratch. Like took us 12 months to build the application, and we had back then and still do. We have like millions of users, and like how do you make sure that like you're building an app that's going to be able to like support that kind of user base when the company is still pretty small? Like there was about 200 of us, so you don't get a lot of beta testers. And like from one day to the next, you have to ship an app. It's going to be used by millions of people, and then like you're going to find out if it actually works. And it took us 12 months because we wanted to build it right this time and not repeat the errors of the past. And we got actually some pretty good results. Actually the only metric that we could use between like the two versions of the app was what the support team was getting. Number of tweets, emails, and people complaining about the iOS app crashing. And from one day to the next, when we shipped the new app, this number went from about 100 per week to 0. And it was actually 0. So it was like a huge success for the engineering team. Product-wise, well, like we can discuss the failings of like the new app or like the things that it got better. But from an engineering perspective, like we nailed it. It was great. And the thing is that since we've built that CI system, since then, we've kept that level. Like the app crashes, obviously, but it's nowhere near what it used to be before, and we're able to keep the crash rate extremely low. So that's the SoundCloud app. And the time we invested in our CI, like we feel now that it's absolutely worth it. As the team grew and as we ship even more features, like the CI allows us to make sure that the previous features still work, and we can spend a little bit less time on QA and more time developing features. So let's talk a little bit about how we work. And actually this changed very recently. So before, there was just 10 iOS developers in one team, and then there's tons of other feature teams, but they don't have like the mobile element. And the transition happened earlier this year, where we kept a core team, and we wanted to dispatch a pair of developers to the rest of the teams. But that's just a theory. So actually what happened is there were many more feature teams than there were pairs of mobile developers available. So we had to make do with what we could, which was shipping some developers alone into one feature teams, and then some developers had to switch between feature teams, and the core team is driven crazy by like all the changes that are coming in, and so like it's pretty tough. But like still there, you'll see like the CI helps us continue shipping things. And yeah, if you want to fill one of these spots in those feature teams, are hiring too. So what we try to do is like we try to pair as much as possible. We used to pair all the time. Now it's not possible anymore. But we try to do pairing as much as possible. If the feature is complex or we just need advice, you can just walk up to another developer and like ask him for advice. We don't do big branches. Like we want to have small branches that are merged back in master quickly, because then you have faster code review, smaller pull requests, and that's why we use feature flags a lot. So if you've never used feature flags before, it's that simple. It's an if-else statement. We have this library called flip the switch, and you can just, like when you develop this new feature, you just add a feature flag, and then you can use it in code. Like we generate Objective-C code, so like when you remove a flag, you just have to fix the compiler errors, and then you've removed everything. And we even have this little handy UI where you can switch features on and off in the app. So this didn't happen like in one day. It was actually a very long process. So when I joined in 2012, we only had one Mac Mini that we called Chaos Monkey. There was 3 of us, and then the team grew. We hired our first test engineers to help us build our continuous integration system. But we still had like the single Mac Mini running everything. Then the team grew. The build took longer and longer, so we needed more Mac Minis, so we got more Mac Minis. And then the team grew again. We've hired 2 new test engineers to help both the iOS and Android team, and the number of Mac Minis increased as well. But the thing to keep in mind is that like we started super simple. The first thing that we wanted to do, we wanted to have an automatic deployment system for alpha and beta versions of the application. We started with this. You push a commit, and then 5 minutes later, you get the new version of the app on your phone. And this already changes everything, because you can distribute this to the company, and you don't have to do any manual things. Like it's all automated, and this like I highly recommend. Then we decided to stop doing this. Like you can't ship like serious software by still doing product archive, because then there's too many mistakes that can happen. Like it happened to me. Mistakenly, I was about to release the app, and then accidentally typed something which changed like an image name, and then shipped this. So it was like an icon missing. So we stopped it. Now we have the builds ready, waiting for us on Jenkins, and we just ship this to the App Store. No manual process in building the app. So basically, we started with like unit tests, alpha beta builds, and an app store shippable build. Very simple, but like it's an excellent base to build upon. So now I'm going to talk a little bit about our current system. Essentially, it's 3 phases. First, we build the app, we run analysis on the code base, and we run the unit tests. Then, next phase is to run the acceptance test, and when both of those phases pass, we can actually create the builds. Each phase is dependent on the previous one, so if one of them fails, we stop there. This process takes about 20 minutes. So we have like 10 minutes of build analysis and unit test, 10 minutes of acceptance test, and it takes about 3 minutes to compile and sign the app. Now I'm going to look a little bit at the details. So first phase, build analysis and unit test. So what we do, like everything happens on one machine. And so we're going to start by checking if we need to run unit tests on local libraries. Then we push internalization strings back to a service. So like if you add a new string to like your localizable file, then it will be pushed automatically to our translation service and translated. Then we install dependencies, we build the app, there's a linting process, we run the unit test, and then we actually build the acceptance test one. So we use CocoaPods for dependencies, and after working with CocoaPods for a long time, I know that it's a great tool to get started quickly, but it presents some interesting challenges as you scale, both in build times and also maintaining dependencies between your local private libraries. Facebook just open sourced Bug, their build system that they did for Android, now works on iOS, and that's like a really interesting alternative. And there's also Carthage that would encourage you to look at for larger projects. So this first step, like building the local libraries and running the unit tests, we have about 20 local libraries, they're local pods. And this phase is only run when needed. So only if we detect a change in one of the local pods, then we're going to run this. And it's all to keep the build times and the CI times as quick as possible. So inside of those libraries, like there's around 3,000 unit tests, and we try to extract as most unit tests as possible from the main app so that we can build faster. Because in the main app, right now we have about like 7,000 unit tests. And when you have that number of unit tests, it's just like it takes a long time. And while I'm talking about unit tests, one thing to keep in mind is that, so this number, like 7,000, it's a pretty big number, but the thing is that like we don't focus on the number. It's just like we got into this habit of like writing tests all the time. And as you do more and more tests, actually like your code gets better naturally, not because it's tested, but because you're able to test it. If you have a class that's impossible to test, then it's most likely because the class is too complex. So then you just split it up, and then the tests are more simple. So like actually this grows very quickly, the number of tests. The linter is pretty strict, and it has like some basic rules. So like a class can only have maximum of 500 lines. We check like every method has to be very small. And this just helps like good development practices. And it allows us, like when we do code review, we don't have to tell a developer, your class is too complex, or this method is too complex. The linter is telling this for you. And as Michael mentioned, like this morning, when you're managing a team or you're working in a big team with like developers that are more juniors than others, like this prevents you from having to like talk to them about like critiquing their code. It's just the system is going to automatically tell them that the code is not good even before they push it for review, so they can fix it themselves. And finally, the last step is to prepare for the acceptance test. That's where we build the artifact that is going to be distributed to the build machines. So let's talk a little bit about the acceptance test. So that's like the big part. We use a combination of Frank and Cucumber to run our acceptance test. Why, would you ask? It's a good question, because it was state of the art, I mean, kind of, in 2012. No, it's not. Like the project is barely supported, so if you were to start today, I would strongly advise you not to use those. But they do work. So essentially, like Frank is a small HTTP server that's embedded into your app, and you can communicate with Cucumber, like who drives the test. And then there's a back and forth where you can see what's displayed in the app, and then you can drive touches and things like this. I'm going to mention Facebook again, because they have the iOS web drivers, which are pretty awesome. So I would encourage you to use those. And Apple finally came on board with UI tests at last WWDC, so that's probably a very promising avenue. If you start running acceptance tests, just look up page object models, because it will save your life. So page object models are very important. So how do these work? So basically, you have your command line, and you just like run a command, and it's going to start the simulator, open the app, and then there's some tricks. We have like an app that deep links into our app, to make the test a little bit faster. Then it drives the UI, opens the player, or it's playing. Then it's going to go back, and then it's going to play. So we have a lot of these tests, and essentially, like they're mimicking like a user's actions and something specific that should happen product-wise. So like right now, I was testing that if I start playing a track and there was a playlist before, the playlist tracks are actually loaded into the play queue. And the thing is that all of those small things that you would have to test all the time, now you don't have to, because they're tested automatically for you. One question, though, is like, why do we use the simulator and not real devices? The simulator provides you a very flexible platform between devices and OS version. You can do some pretty cool hacks, like simulating bandwidth, turning the network on or off very quickly, that are like harder to do on devices. You can use launch arguments when you launch an app on the simulator, so we can start the app already logged in, those kinds of things. So they're like really cool. We use the command line tool to launch the simulator. The app communicates to the mobile API through a proxy, and the proxy enables us to change response status codes, the response body, and record and undo actions. So when you like a track, the track is going to be automatically unliked once the test finishes. So that's great. Like, imagine having to test all the failure scenarios of like, oh, what if this endpoint returns 500? And like, now we don't have to. Or you try to sign up, and then there are like tens of different alert views that can be displayed depending on the status code that you get. And this is super hard to QA manually, but with an automation system and a proxy, it's very easy. The drawback is, since we're using the mobile API, we're using real data, so we have to create a lot of test users to that each have like independent content and that don't interfere with each other. But even with this, sometimes when you run the test in parallel, like one test can screw up another one, so we get a little bit of flakiness because of that. So how many of these tests do we have? We have about 350 acceptance tests. And if we were to run them on one machine, it would take about 200 minutes for all of them to run. And obviously, like, we can't wait 3.5 hours to know if an integration was successful or not. So that's why we need more Mac Minis. And so we came up with a thing that we called like distributed cucumber. And so basically what happens is that we have a cluster of Mac Minis, and we will distribute the test to all the machines that are idle. So this provides equal distribution of work. So each machine that is available is going to pick up one of the tests from the pool, and then once the test finishes, it's just going to take another one. And that way we can optimize the use of the machines. So right now we have about 20 Mac Minis. And since we're running the test in the simulator, we can also run the test in a virtual machine running on this Mac Mini. So actually, each Mac Mini, you're able to run 2 virtual machines on them. So that's 3 simulators per Mac Minis. Essentially, yeah, that's a lot more machines to build things on. And I'm going to mention Facebook again, because they released 2 days ago Facebook Simulator Control, and apparently now you can interact with multiple simulators running on the same machine. So we might not have to do this trick anymore. But it was pretty awesome that we figured out how to. So that's the acceptance test, and that's how we keep them under like 10 minutes. So right now we're working on something, and like we're able to like perform a run of the acceptance tests with like different versions of the application, different phone versions, iPads, and different feature flag configurations. And an interesting thing is that I remember before we shipped the app, we hadn't used the app on an iPhone 4 in a long time. And then we did an acceptance test run on the iPhone 4, and they all failed, or like most of them failed. And the reason why was that you couldn't actually press one of the sign-in buttons because it was outside of the screen. And like we all have like the fancy phones, and sometimes like you forget about the 4, and like it's nice to be able to run like the full acceptance test on those. So I've talked a lot about the value of the acceptance test, like all this investment, is it really worth it? And like again, you can avoid regressions on hard to test screens and flows. I talked about the sign up and the sign-in flow, and now I'm going to show you an example of what we call the collection screen. Usually that's what you see, and that's what I see every day because I'm an engaged user of SoundCloud. So like I have a lot of likes, I have a lot of playlists, but we have like a lot of different users on our platform, so we have to make sure that the app works for all of them. And this particular screen has many different variations. So you can have a variation with both likes and playlists being populated. But there's also, what if the likes are empty? What happens then? What if the playlists are empty? What happens then? What if you have no likes or playlists? What if you don't have any network connectivity? And all of those little things, like the little details that make your app like really great, they're super hard to QA. Like you're going to ship them once, and they're going to work. But then at some point in the future, you're going to do some refactoring, and then they're going to stop working. And since like you're not testing them all the time because it takes too long, you're just going to lose the features. And having a big acceptance test suite like helps you maintain the quality on all the little nice things that make your app great. But it's not all like unicorn and puppies in the CI world. A big problem is keeping the build green. It's really tough. And a lot of times, like that's what our Jenkins looks like. You have like a chain of red builds, and it's extremely frustrating. And usually, after a while, like you manage to fix the problem. But the big issue is that if the build is red, it blocks your entire team. Like no one can push. And we're very strict about this, because if you push on a red build, like you increase the chance of like something, like some more things breaking, and then it's really hard to pinpoint what actually broke the build. So basically, like no one can push, so the team is stopped. So what we are trying to improve on is our pre-CI system. It's a collection of scripts that we can run before pushing, and also running the full continuous integration when you open a pull request on GitHub. And there's a nice GitHub integration, and when the integration is green, you get this nice little check mark there. And it's actually pretty tough to get the check mark, because we're still using this rule that says that, oh, yeah, play, yeah. So it only takes like one failing test to break the whole build. And the test fails sometimes. It's like SpaceX, not much went wrong. Like they probably got 9 out of 10 things right, but one failed. So like the entire mission failed. And it's the same with the CI. And the prime are flaky tests. So what's a flaky test? What makes a test flaky? So you can have the test driver being flaky. Sometimes Frank just doesn't tap or misses a tap. You can have a flaky backend. What if the search suggestion endpoint failed? What if SoundCloud is down? Then like the acceptance test failed. But sometimes the app is unpredictable. Like what if there are race conditions, and sometimes things work, sometimes they don't. So you can't just like dismiss a flaky test and remove it from the test pool. Like you actually have to identify the flaky ones, isolate them, and fix them. And that's key in keeping your acceptance test system working. Because when the tests are read, or like when the build is read randomly, it's very frustrating for the developers, because then you stop trusting it. You're just going to be like, oh, it's red this time, I'll just rerun it. Maybe it'll be green. And the prime is that like you really have to investigate why the tests are flaky. Because most likely, it's either you wrote the test wrong, or there's an actual deeper problem in your app. And we use core data, so like we get a lot of those like really weird crashes that happen once in a while, or like why is the data empty? And like we found out that it was because of like race conditions that we had in core data, and we really had to investigate them to figure them out. But we're currently working on this tool called the Flaky Razor, and yeah, it's kind of also inspired by, by what Facebook's doing. And it's basically like so all this process of like identifying like why did the test fail, like isolating it and trying to fix it. Right now, like it's manual, but like we want to automate this. And what we would like to do is to take the failing test out of the test pool. That way the build is green again, and we can continue working. We can run the test multiple times to figure out if it's flaky or not. And then we can assign that failing test automatically to the person who committed it, and they can fix it. But also, we can assess the test value. And it's pretty difficult to know if a test is good. And recently we spent a full day, the entire team, just looking at all the acceptance tests. And some of them, like, they haven't failed for 2.5 years. And then you're asking yourself, like, is this still a good one? Like, does this test make sense? And we found actually a lot of stale tests that were essentially not testing anything, or they were like always green, and because they shouldn't. And yeah, so like you have to like maintain all of this. You can also like you have to detect when test duration changes. What if a test that used to take 20 seconds now takes 1 minute? That's very suspicious. And we can also show the statistics on why the test failed. So right now it's like pretty experimental, but like we can figure out if a test failed because of the backend, because of the app, or because of the Flaky test driver. But it doesn't work all the time. Yeah, and so yeah, we like taking good care of our build machines. Like we love our Mac Minis, and we would like Apple to ship again those quad-core Mac Minis because the new ones are so slow. We have this little cabinet like in the office with all the zoo. And the Chaos Monkey from 3 years ago now, he's still there, like kicking it. So we have disk images for all the machines, command line tools to provision them remotely. There's an OS 10 server that stores all of this and that controls the imaging process. And yeah, so like sometimes you have to jump in and like reboot one machine, but like the team learns to do it. There's a ton of stuff on the wiki. And that's it. Thank you very much for listening to me. So yeah, this was like, there's a lot of information, and I had to get through them quickly. But if you have any questions, you can just ask me or Megan and Slavko, my colleagues who are there today, and we'll be happy to answer them. Thank you.
Hi, great talk. I was wondering, so the slide that you showed that showed all the huge drop in crashes.
Yeah.
So I was just wondering if you could sort of expand on what do you think the main thing that contributed to that was?
So like we inherited the old application from contractors, and there was like a very short period of time for us to get to know the app, and there was a lot of dark corners that we didn't dare to touch, and a ton of crashes that were undetected for a long time. One of the first things I remember doing is like to fix the crash reporting implementation, which wasn't right. And then from one release to the next, we went from thousands of crashes to tens of thousands per day. And the thing is that it only happened because we fixed the crash reporting tool, so we had no idea like where they were coming from, and it was really hard to figure this out. And that's also one of the things that triggered the rewrite, the full rewrite, which we should never do. Like we regret it, but it had to be done. So I mean, and what triggered it was mostly like the like serialization to disk and like database stuff. Like the old app used SQLite, and now we use core data. But mostly it was like related to this.
Hi, thanks for the talk. Just a note, or like we did the same thing at Xing, basically, like this huge CI infrastructure, and we found that Mac Pros are much more sufficient for it because VMs aren't really supported by Apple on the Mac Minis. So, and also they have a lot of power. So we were able to get like, how many do we have now? 8. Yeah. 8 VMs on one Mac Pro, so you're basically
You're
save.
not really allowed to, though.
What?
That-
What?
I think that there's a limit by Apple on the number of VMs you can run on one machine.
Yeah, but like, what do you? We investigated that too because like the thing is, what would you do? You can't purchase Yosemite. How would you purchase it? There's no server license for it. You can't purchase it.
That's true.
Basically.
I mean, yeah, like you can do this. I think like the Mac Mini was like a good middle point. Because Mac Pros are super expensive. I mean, yeah, like we could buy Mac Pros, but yeah.
Yeah, and they also work we had Mac Minis just
And they're so
dropping.
cute.
Like yeah, it looks cool, right?
Any more questions? Well, you can come to us at the next break. Cool. Thank you.